Hello everyone, and today we are going to focus on averages. Now, जो average है ना, it is generally a central value, or you can say the average. Average is the value that represents a data. मतलब कि अगर एक डेटा है और आपको एक वर्ड में बताना है कि उस डेटा का हर एक पॉइंटर क्या वैल्यू हो सकता है, then we can say that it is an average. For example, if there is there is a data that is 2, 4, and 8. Now, the average of this, and this is by the way arithmetic mean, so the average of this will be 14 upon 3. That will translate to something around 4 point something. That is what average is. Average is the one value that can represent an entire set of data. Now, weighted average. Weighted average is the thing that counts when you have to assign different importance to different values. For example, agar you are calculating, suppose say sales, uh, you are predicting sales. Okay. Now, while you are predicting sales, the sales of previous year and the previous to previous year and the previous year will hold different weights, that is will hold different importance in predicting. That is, if there has been a sale of 10, 10, and 10, then the weighted average will not be equal to 10, because the weights that we will be assigning to previous year will be 0.5, and this will be 0.1, and let's make it 12. This will be 0.4. Now the weights, the average will be calculated such: 0.5 into 10 plus 0.1 into 10 plus 0.4 into 12 divided by 1. That is the sum of weights. It won't be 3. Okay. So it will come out to something around, I think, 5 plus 1 plus 0.4 into 12. That will translate to around 4.8. So it is around 10.8. So that will be your weighted average. It is different from averages. A weighted average is the average that gives different importance to different values in a data set. Average में क्या था कि you will get the same importance, the same thing for every value. But this is not the case with weighted average. Now coming to geometric mean. Geometric mean is a different kind of mean. For example, when when we were talking about mean, it was arithmetic mean. There are three types of mean: arithmetic mean, geometric mean, and harmonic mean. So geometric mean is generally used when you have to calculate compound growth, compound rate of growth, percentages, and the relationship between the data set is multiplicative. For example, what do we mean by multiplicative relationship? That it means it means that after a year, after one data, another data is in multiplication of that. Now this multiplication can be constant and other things, but the relationship between these two data sets is multiplicative in nature. And how do we calculate geometric mean? That is under and under. That is, this is not a square root. This can be a cube root. This can be a quartile root. This can be a, penta root. This is not a square root. Okay, it can be a square root. It can be anything that n is. N can be 5, n can be 10, and can be anything. And the values um, inside this will be multiplicative in nature. Okay. And then you have to calculate, for example, just for an example, if we have something like this, 3 under root 9 is to 9 is to 9, then the geometric mean will be 9. Okay. So this is how you calculate geometric mean. And these are generally used when when you have to calculate relative performance. Okay. Harmonic mean harmonic mean is a type of average used when you are working with rates like speed, price, basically when you are calculating something per unit. That's when you use harmonic mean, when you are calculating something per unit. And the way to calculate harmonic mean is number of values. For example, I have a data set that is 9, 5, and 8. Then the n will be 3, and upon n there will be 1 upon 4, 1 upon 9 plus 1 upon 5 plus 1 upon 8. And that's how you calculate harmonic mean. Harmonic mean is generally used when you have to, you have to do financial ratio analysis and and things like that, or you have to calculate average time, speed, or cost over a fixed distance or a task. So that's when harmonic mean is used. You will get to know more about it when you actually solve some problems. Before that, it will be a little hard to digest, but okay, we can get through it. Now, coming to some shortcuts, because every time you cannot just go to arithmetic mean and put that tedious formula of, 2 plus 4 plus 6, and then you have to divide by 3. There are certain shortcuts for certain particular thing. For example, first n natural numbers. First n natural numbers can be calculated like this. The square root of first n natural numbers can be calculated like this. And the cubes of squares, sorry, not square root, squares of first n natural numbers, average of squares of first natural number can be calculated like this, and so on. The cubes, the average of cubes can also be calculated like this. For example, if you get a data set that is like 8, 64, 125, then you it will be tedious for you to actually calculate the arithmetic mean. What you can do, you can calculate the averages of the cube, because this is 2 cube, this is 4 cube, and this is 5 cube. Okay, so that's how you do the things to make it easier and to solve the questions really fast. Now the even numbers can be, basically these are the formulas to calculate the average of first n even numbers, averages of squares of first n even numbers, and averages of cubes of first n even numbers. So that is all. Now odd numbers. So you just have to remember this formula and use it when you think then it is beneficial for you. More videos will be coming soon, and this is the day one of CAT. Happy learning. Please, if you want, you can subscribe. Thank you.